This is 1.7, Solving Inequalities. Many of us are used to the linear inequalities, and we take 4x plus 3 less than or equal to 15, and solve for x, and we get x is less than or equal to 3. And what we're used to doing is something like this. We draw a number line, and it says less than or equal to, and we're used to like a filled in or a closed circle, and it's less than or equal to. So we, it's everything to the left-hand side of that. So, and you can do it that way as well. Remember also there's the way to do this, let me back that up, is the closed circle that we often are referred to, that's the same as a bracket. When you use brackets, and when you have an open circle, that's parentheses. So we could also do a bracket, because this is closed, and it's going to the left. Now, this way is kind of preferred just because when you type it in interval notation, it's an exact duplicate of the line. So literally just copy that down, put a 3 there, and notice it keeps going this direction, keeps going that direction. And what is that direction? It's going all the way to negative infinity. And you can never actually include infinity. It's not a number, so we're going to put parentheses. So this would be the interval notation for solving this linear inequality. All right, so let's try another one. Again, we're going to solve this compound inequality. This is linear again, linear because it's x to the first. And so we're going to get 3x. We're going to add 2 to every section. Add 2 in the middle, add 2 on the right, add 2 on the left. And then divide by 3. Now, so that this interval notation, the line, first of all, will look like this. So we have 2 and 5. And notice normally here we would put a closed circle. Here we would put an open circle. But let's practice using the brackets and the parentheses. That way it's an exact duplicate of the interval notation. So here we're going to use brackets because it's has an equal sign with it. Here we're going to use parentheses. And it's all the numbers in between 2 and 5. So the interval notation, again, exact copy. We got bracket at 2, and it's going to go all the way to 5 with a parenthesis. So it's all the numbers in that interval between 2 and 5 that will actually work. I mean, it's going to be greater than 4 and less than 13. That's greater or equal to 4 and less than or equal to 13. These numbers will actually work when you plug them in. All right, so let's start talking about nonlinear, because nonlinear throws a different ball game in here. So if we solve for x on this, and what you're going to do on this is basically pretend for a second that it just says equals 0, and you're going to solve by factoring. And so we're going to get x equals 3 and x equals 2. Now, what we have to consider on a number line notice in between 2 and 3, these numbers on the number line, I actually have 3 intervals. So this interval here, it's talking about all the numbers from negative infinity all the way to 2. Here, this interval is talking about from 2 all the way to 3. And this interval is talking about from 3 all the way to infinity. So something I've kept emphasizing over and over is we got to always check our values to see if they actually work. So what we're going to do is we're going to pick a value anywhere in between, in this interval, we're going to pick a value somewhere in between that. And it doesn't make a difference. I would choose something nice like 1. So let's try x equals 1 and see if it actually works. And then we're going to try some number in this interval, and we're going to see if it works. And again, any number in between there, let's just say 2.5. And we're going to try some number in this interval. It does not make a difference, but here, let's just say x equals 4. And we're going to see if those intervals will work. And remember, you always want to plug it into the original problem. So let's just start off with 1. So 1 squared, we're substituting this number in right here to see if that works. So, and then if it does, then everything in that interval will work as well. So we're substituting x for 1, and so we're going to get 1 is less than negative 1, which is false. That is not true. 1 is not less than negative 1. So this little interval from here to here does not work. All right, and then we can do the same thing. We're going to try x is 2.5. You plug 2.5 into where x is, and we're going to see it does work. And we're going to try 4. So we're going to take 4 squared. Remember, we're plugging into the original problem. And we're going to see that it does not work. So the only interval that works is in between 2 and 3. And something that you need to be aware of at the very beginning, this was less than or equal to. So it's in between 2 and 3, but it actually includes 2 and 3. Like if you literally checked 2, it would work. If you literally checked 3, it would work. But see, the original problem is telling you those are going to be brackets anyway. So that's how you literally need to check every single interval to see which one works. Let's try another one. So the same scenario in this, what we're going to do is bring everything over to one side. So 2x squared minus x minus 1 is greater than 0. And then what we're going to do is solve this. And I solved it by factoring. And then we're going to, again, pretend it says equal. So when we set that equal to 0, we're going to get negative 1/2. We're going to set this equal to 0, and we're going to get positive 1. All right, so on the number line, we have our two numbers. We have negative 1/2, and we have 1. So again, think of these intervals. This is from negative infinity all the way to negative 1/2. This is from negative 1/2 all the way to 1. And this is from 1 all the way to infinity. Those are my intervals. So what we want to do is check some random point, whichever number you want to check in there, to see which ones work. And again, I would probably choose like negative 1 and then see if that works. And then probably some number in between there, like 0. It's a nice number to check. And then probably check some number in here like 2. And then see if they end up working. So once you plug those in to see if it works into the original problem, see if it works, you'll see that this one works, this one does not, and this one does work. So notice it's a combination of this interval and that interval, and that's the way we're going to write it. So we have negative infinity all the way to negative 1/2. So any number in that interval, and it's the union of the other one. So 1 to infinity. Again, this is the union symbol, so it's literally combining this interval and that interval will work. And notice I do have parentheses. We could have noticed that at the very beginning. We're going to be using parentheses on our intervals. And that's 1.7, solving inequalities.